Hello my friends and welcome to FISHTORY. I'm Alexander Williamson and today we're going to be talking about cyanobacteria, which is a fascinating topic to me. And it's something that I've covered in past videos, and we talk about when cyanobacteria, also known as blue-green algae, occurs up in your water column, or up where the fish are living, obviously, on top of plants and surface areas, and it blankets things. That's different than what we're talking about today, which is when cyanobacteria and archaea and fungi and other sorts of life form are growing down in the substrate of your aquarium. Now, what's different about this bacteria slash algae is that bacteria can live off of nutrients in substances like our substrate. And that's pretty cool. But plants can take nutrients from the sun, which is pretty awesome. So they can actually turn the oxygen, the water, and the sun into energy. And cyanobacteria is a combination of both of those organisms, essentially. Now, today we're not going to get super into the deep science of all of this or the species, but we are going to go over the various kinds and what it's doing in our aquarium, because cyanobacteria is the stuff that chokes out lakes and closes down beaches. It kills fish by the billions every single year, and it creates a whole class of deadly compounds known as cyanotoxins. Likewise, it's also a very fascinating group of organisms because spirulina is a type of blue-green algae, and it is considered a superfood that we feed in wafers and pellets to our fish, and that has even been, heralded as something that could save humans and help prevent food insecurity in times of starvation or malnutrition. So, what is the blue-green algae up to that's in our aquariums, and is it here to save us or here to harm us? And what is its impact on our fish, shrimp, snails, and plants? Let's talk about all that and more and take a look at it in today's episode on blue-green algae. Alright, right off the bat, I want to show you guys some of this banding in an aquarium that's about 5 years old, the Substrate, maybe 6 years old now. And you can see where the roots are, right? So you can see that the roots reach down into these layers of different color bands. Now, these different color bands are minerals, bacteria, fungi, archaea, and also another substance, cyanobacteria, which is today's topic, right? But you can see down here that we've got what would appear to be algae, this green colored organism here. What this is cyanobacteria. How do I know this? Well, it's because there's no oxygen that low. Under inches of substrate, there's no oxygen. How do I know that for sure? Well, these pockets here of this orange colored material, this is rust and sulfur. So it's iron and sulfur that bacteria has deposited there. So it's taken it out of the little pellets of the aqua soil above and the mulm from the fish waste and the shells and everything else that's in the substrate. And it has deposited it lower and lower through Brownian motion over time. And it settles down. And if it gets light from the outside, it will grow as kind of a typical blue-green algae. Now, this is probably what you are most likely seeing if you're watching this episode because you searched for this topic specifically. But what you can also see going on here is kind of a purpley brown colored growth. And that is actually a whole class of bacteria that we don't talk about much in the aquarium hobby usually. And it's called, fittingly, purple bacteria. So let's talk a little bit about all of this and the roles that are being played here. And we'll go look at another tank that illustrates this same sort of thing. It's a different age. Alright, so here we have a heavily planted aquarium, happy fish, everybody's doing their thing. The water moves in this aquarium, there is a filter moving up there, hang off the back, and so the water in the water column is oxygenated. And because of that, when you see green things growing, like this green algae here, this diatom algae on the stone, that is algae that requires oxygen for photosynthesis. When you get down into the substrate, and you get below the mulm and the silt layers, within an inch or 2 inches, you can approach anoxic or anaerobic conditions, which means there's no free oxygen there. And here you can see it starts within about 1.5 inches, and we see what you would assume would be algae, but it is not. It is cyanobacteria, or as we said, sometimes it's called blue-green algae. Now, it's called blue-green algae because, let's see if we can get the angle just right without the reflection here, but sometimes it looks kind of bluish, kind of greenish. And when it's growing up into the soil, it can be a real problem. It can grow up and carpet everything, and it can actually choke out the plants so that the actual leaves can't perform photosynthesis. Then when it dies, it actually causes an ammonia, a nitrite, and a nitrate spike, all because it is biological debris that's breaking down. Now, normal algae can also cause this, and a lot of times that will be called eutrophication, when we have way too many nitrites or nitrates or phosphorus in the water, and algae blooms to the point where it chokes everything else out, including the sunlight at the top of the water. Now, it's usually free-floating algae that's responsible for this, but cyanobacteria can also do this. And when it's free-floating like that is when it's generally the most dangerous. Now, there are different forms of this in different places, different ecosystems all over the world, but the most dangerous are going to be the kinds that give us things like red tide that grow in massive ecosystems where there's a big hole to fill as far as different organisms taking up different nutrients. Now you can see here, there's planaria, which are usually a pest, but in this tank, they're not so much a pest. They don't have any shrimp for them to eat, and baby fish have plenty of places to hide, so they're actually a food source for loaches and other fish. But the snails in this aquarium, you can see here, they are actually bringing up the cyanobacteria that was down below, and every night they churn it up like moles. And you can see the little pathways here that they make, like right in here, when they come up and surface in the nighttime, which right now it's early in the morning, so they've already done their thing. And yet, the cyanobacteria is not spreading. So when you see cyanobacteria in your substrate, it's generally not the same kind that's going to thrive up in the oxygen. And that's because this cyanobacteria relies more on the thing that makes cyanobacteria so special in the first place, which is that it can take energy out of things like sulfur or things like iron in the actual substrate itself, and it can use that to create energy and grow new life. Now, while it's doing that, it forms these colonies, and because in these low oxygen regions like this, no other bacteria is as well equipped as it to grow, it is what takes over. So if it wasn't there, you would see this over here. And this is showing you that it doesn't grow much at all when there's not enough light. So we know it's a cyanobacteria that actually needs light as well. And I can tell you from experience of simply lifting up aquariums and looking at the bottom of them where it's been dark, that this same cyanobacteria doesn't really grow on the bottom either. So this cyanobacteria that you oftentimes see right on the front of your aquarium is just that. It's very surface. It's only as deep as an inch or so because it's only connected with the network so far to get nutrients, and it needs that light. When it doesn't have natural light or enough light, it can't thrive. So there's a little bit here on this side, right in here, but soon after that, it runs out. And so this soil is rich with all sorts of bacteria, I'm sure, but it's not hosting the cyanobacteria. So beside the point of asking, is this cyanobacteria creating any sort of toxins like the bad cyanobacterias? Well, it probably doesn't matter because there isn't much of it. Just like over here, on this side of the other aquarium we were just looking at, there is some cyanobacteria growing, and it's just where the light shines from this aquarium over to this one. So this is a low oxygen, but it needs light bacteria here. If we go to the back, it doesn't exist. If we go to the side where it's actually getting more sunlight over here, you can see it starts to grow thicker again into more mats. So this is probably benign in that it needs no oxygen, and it's thriving in the area with no oxygen because it can't compete up in the higher levels where other algae, just plain old-fashioned algae, is trying to take over. And when you have a tank that's old and very diverse like this, you can see that there's algae and mulm and probably bacteria and fungi all over, but no one species is taking over. Even though it's all growing a little bit here, a little bit there on surfaces in the tank, no one has become the dominant one. And I like this system in nature tanks. Now, if you're doing aquascaping and using aqua soil and you've got shallow substrate, you're going to want to keep your substrate oxygenated most likely because plant roots are going to enjoy that more. They're going to feed in that condition better, whereas they will get choked out in anoxic conditions unless they're slowly growing there and working with the team of bacteria to exchange nutrients, which takes time. So in an aquascape tank, especially if it's only going to be set up a year or two, you probably want less compacted substrate. And if you see cyanobacteria, it may be a sign that you're no longer getting oxygen to your substrate. In one of those tanks, you probably don't want mold to build up. You're probably gravel vacking and doing things like that. But if you want one of these nature tanks, then you're going to allow nature to do its thing. And over time, as those big, thick green mats bloom and then die, they leave behind what was inside of them nutritionally. And a lot of them do things like fix nitrogen from the atmosphere, or they actually fix carbon from the atmosphere. Now, to illustrate all this yet again, we have another tank where I have Malaysian trumpet snails. And yes, they're stirring up the substrate. And we can see that the roots of the plants are growing in this top dense mulm layer. It's kind of fluffy, but it is fairly dense mulm for water to get through. And then down below that, there's the loose sand layer of different sizes. And so it still has oxygen. And so the roots are growing really well, really dense there. And they're feeding out of the nutrient layer, which starts to lose oxygen. As plant roots go down, they can actually do a trick, which is to bring oxygen with them down into these deeper areas. As you can see, though, as it gets deeper, they run into the cyanobacteria. And the cyanobacteria in these voids in your aquarium is really not a problem, as you can see it growing here, because, like I said, it is growing with light and low oxygen. As soon as it runs into high oxygen, see right here, it stops thriving and something else outcompetes it. Now, there are exceptions. There are other kinds of funky little algae or fungi and things that end up in your tank, and that's something you can keep an eye out for. But as long as your cyanobacteria, no matter what color it is, whether it's something like this blue-green here, or it's something like a brown or red, which actually is growing right in here, it's a little hard to see, it's okay, because it actually establishes a mutual relationship with plants in most cases where it's in low oxygen. And it starts exchanging sugars for other nutrients and for nitrogen and nitrates. So it can do things like sequester ammonia down in the oxygen-free levels, and your plant roots can go right to the edge of these levels and basically knock on the door with their roots and say, hey, can we trade? Can we have some of those nutrients? We'll give you some of ours, and we'll stay out of your area. And they establish fungal and bacterial, what we call mycorrhizal networks, which is a really complex topic, but a really fascinating one. And without this, the fungi can't live down in the areas without oxygen, and the plant roots don't do well without that either, unless they're nice and thick and connected to a network of plants above that are up in the oxygenated water that are getting their energy, obviously, from the sunlight through photosynthesis and supporting a vascular network with the nutrients they've got above in the water. Now, here is my oldest tank, and I wanted to show you how quickly this can occur. So if you have an old tank that has very dense mulm, very fine particles of silt that have compacted, this is less than an inch or so deep, and already we get to our oxygen-free layer. Because remember, that rust line, that's where the bacteria and cyanobacteria that liked iron died out after many, many generations. You can see the process is still going on down below in the oxygen-free area. And it's creating new bands right where it's dying. See the edge of this? There were probably plant roots coming down into this little bowl, and they probably brought oxygen with them to surround the soil and substrate, which then killed off the cyanobacteria that was living there. Is probably the plant that I dug out that was actually right here. There's still a daughter plant left of it. But it's fascinating because it tells a story of what happened in the substrate. Now, I want to show you one last thing before we end this episode, and that is the purple bacteria we were talking about here. It reacts to UV light, which is pretty cool. So beyond it actually having a slight burgundy or purple kind of color to it here that you can see, it actually will fluoresce in the black light. So let's take a look. So the purple bacteria, as they call it, actually glows that red color. The rest of the debris and substrate just has kind of a purple hue, but when you see it light up with this bright burgundy and pink color, that is the UV reactivity. Whereas you can see above that, it's more of a blue color, and it stops reacting right in here. It gets thicker right here as the oxygen runs out. And that's because purple bacteria is specifically bacteria that doesn't need light whatsoever or oxygen. It can live off of merely nutrients in the substrate, which is pretty bonkers, and maybe how life lived through several extinction events. So at the end of the day, all of this bacteria is fairly harmless when it stays in its place and when you have a well-cycled, well-balanced tank, because it will simply die when it comes out of its lair. For instance, here we have a brand new aquarium just done a few months ago, and you can see there's a little bit of algae there, But there's no development of bacteria or cyanobacteria or any of this. It's just normal structures you'd expect to see. But as soon as I have loaches that are excavating things, it's going to kill that, and it's going to turn it around, and something will fill in, whether it's algae up here on the rocks that's kind of starting, or whether it's cyanobacteria or normal bacteria or fungi. But all of it is designed to work in this ecosystem together, and all of it is designed to be part of our living ecosystem. So unless it's getting out of control, and this is true with just about everything in your aquarium, if there's just a little bit of it, let it be. It's probably fine. Even if it is slightly toxic, it's not super toxic to that extreme, and it's staying separate from the rest of your water column for the most part when it stays down low. So if you see cyanobacteria in the substrate, you can let it be and let it do its thing. It'll stay there for years at a time, fixing the nutrients and sharing with the roots, and it won't be an issue unless it gets disturbed. Now, if it gets very disturbed, Tom Barr suggested do a water change for safe measure. Make sure that that ammonia and other stuff that could be in your deep substrate tank gets changed out. And that's good advice if your deep substrate tank gets disturbed severely in any way anyhow. So I hope this helps you guys alleviate some fear and understand what's going on in the aquarium a little bit better. If you want to know more and more details about all this, please let me know in the comments. I'd really appreciate it. All right. Whoa, you guys made it to the end of the episode. Thank you so very much. You are in the minority. Not many people make it all the way to the end of episodes in long-form content, and I have to thank you so very much. It is because of people like you that this channel exists, and I really can't do this without you. It's still dark out here. It's still morning. Trying to hurry this up before the birds start chirping. I'm Alexander Williamson, and I'll see you guys next time on FISHTORY. Thank you so much for joining me, and have a wonderful day.